And you are live.
All right. Hello, world.
Hello, world. And absolutely. So now we have to wait for people to start funneling in.
Where do I see that on the chat window?
So there's the number at the top of the chat window on your right sidebar.
Oh, I see.
As people start funneling in, that will start updating. I think it. I forgot what the interval is that it updates. The webinar software might not actually let people in until exactly 2 o'clock.
Oh, okay.
So that's probably why we're not seeing anyone. So let me.
Be a real blow to my egos otherwise.
Your webinar has 0 attendees. All right, one person's.
Yay!
We got our first person coming in, so they'll start filing in now.
So it must be the time thing because it's almost 2 o'clock.
And what I tend to do is, as people file in, just wait a couple minutes, let folks chat, and then we'll go into introductions, and then let you start talking to everyone, because that's why they're really here. They don't want to listen to our banter. David, is this being recorded? Absolutely, it's being recorded. Tomorrow, it takes about 24 hours, but you'll get a replay link, and it will have have all this banter for you. But don't let that keep you. Don't let that make you leave. I mean, you should stay for the live course, because then you can ask your questions, and you can get immediate feedback from Frank. You don't have to wait for Frank to respond to social media or emails or anything like that. Hey, New, how are you? New is a local in my area.
Thanks, David, for sticking around. That's awesome.
Awesome. So, Frank, I am at this wonderful conference called Tech Bash in Poconos Mountains, Pennsylvania.
Oh, very cool.
We are at a Kalahari resort. So if you know what a Kalahari is, it's an indoor water park. It's one of those. Bring the family for a weekend. You don't really have to go outside ever. Everything's all included. It's not inclusive because you have to pay for everything. And we went to a steakhouse last night, just downstairs, and it's Ruth's Chris type steak prices. It was a really good steak, though.
I was gonna say, is it Ruth Chris type steaks? Then
it was really good. I enjoyed myself last night with that steak. And so tonight we have a party and stuff, but I skipped out of the conference for a little bit of time so I could hang out with you and all of our new friends. But it's 3 days. This is Tech Bash's sophomore conference, so it's their second year. And they're you and I have both been running events for an extremely long time.
Longer than we care to admit.
And you know the growing pains of an event. The first year is always the scariest one. The second year, you're starting to get a little bit of confidence. And then third year, the conferences basically just run themselves.
Right.
You got to get into that flow.
What year are you on at Revolution Conf?
We just had our second event, so we're aiming for number 3. So Revolution Conf 2018 is May calendar. It's I should know this off the top of my head by now. It's May 17th and 18th in beautiful Virginia Beach, Virginia.
Very cool.
Frank
it's a nice hotel. Is it the same hotel this year?
Same hotel. Yep.
Good hotel.
We got committed early with them.
Awesome.
So you're right off the beach. Literally, you just walk out the back door. There's a beach. We had tons of amazing speakers. Frank was a very last minute speaker because we had someone drop out, and Frank was available. And we loved having you, and you got a lot of good reviews on your talk.
Oh, awesome. Cool.
So
I had fun giving my talk.
Yeah, and that's kind of the essence of Revolution Conf is we just want everyone to have fun. We don't want to put people into their little baskets of you're a .NET developer or you're a Java developer, you're a Python developer. If you sling code, you're awesome. So exactly. We want you to come hang out with us, and I want to learn from everyone, and hopefully maybe someone wants to learn from me.
Right.
And that's the whole essence of SwiftKick is we just want to teach. And we want to learn. That's what makes us the world go round.
Exactly. And the world is like that now. It's not like you can now have, if I'm a Java developer and I want to play around with Python, it's a quick install. Or if I want to be super lazy, I can just spin up a VM somewhere with all these tools already installed. And as they say, where I grew up, bada bing, bada boom, you have this entire development environment already set up in minutes. I mean, that's, you've been around long enough to remember where you had to reboot the machine or install the CDs, and it was not a trivial thing to set up a development server. Or just even, you don't even really need a development server anymore. I mean, you run it in the cloud.
All right. Well, I'm going to go ahead and kick things off.
Cool.
And people will join us as we go. And so let me hit start on our slide deck here. So hello, everyone out there in the ether web. My name is Kevin Griffin, and I am the owner of SwiftKick. We are a training and consulting company based out of Chesapeake, Virginia. And this webinar series is kind of our goodwill back to the community. I am not where I wouldn't have gotten where I am today if it wasn't for the community and just being actively involved and learning from some of the best people I've ever met, and also trying to give a little bit back here and there. Frank is a great example of someone I just have learned tons from over the past 10, 11 years I've been doing this. So our mission is to just give back. And if you find yourself in a predicament where you need some training, if you need whether it's .NET, big data, data science, you name it, come talk to SwiftKick because there's probably a way that we can help you out. I would love a little bit of love on social media. So if you're on the Twitters, if you're on Facebook, if you're on LinkedIn, please take a moment and just give us a follow or give us a shout out so people know that you're attending one of our webinars. Because you're in the webinar and you've registered, you're also now a member of our email list. So I'm really not going to try to spam anyone, but I'm going to send you reminders about some of our upcoming webinars because we try to do them every 2 weeks. And we have some really exciting ones coming up here in the future. For example, in 2 weeks, a very good friend of mine, Kendall Miller, will be talking about real-world UX problem solving. He's the owner of a company called Gibraltar Software, and they just did a major UX, UI refactoring of one of their big products. And he wants to come and talk about some of the lessons learned from that entire experience. You will get an email about this next week, so you don't feel like you have to sign up for it now. But if you want to, go to the bit.ly link here on the screen, SK Real World UX, and you can just jump into that webinar and be ready for it. After that, on November 2nd, which is not a Wednesday, it's a Thursday, another friend of mine, Sean Marin, will be doing kind of a different talk. It's a soft talk, but it's called Live to Code, Don't Code to Live. One of the things I do in one of my other lives is I host a podcast called Two Frugal Dudes, which is all about financial financial independence for layman's. Sean is my co-host, and he goes around and he talks to people about, how do you take advantage of what you already have, and how can you set yourself up for financial success when you're a technologist or an engineer. I've listened to this talk a couple of times. I highly recommend it, and Sean's gracious enough to come share it with us. And then after that, another friend, Frank, I know you've known Joel for a very long time as well.
I have.
Joel Cochran will be with us, and I'm not quite sure about what his topic is, but hopefully by Kindle's webinar, we'll have all that settled up. And
so Kevin, if I may interject.
Yes, absolutely.
I don't want to be that guy. Kevin, Joel and I worked together on the same team at Microsoft, and I know some of the things he's worked on, some of the people he's actually rubbed elbows with, and I know kind of what he's doing now. That whatever he talks about is going to be extremely interesting. That's all I'll say.
And he's doing probably not too much different than what you're talking about in the big data science realm.
Exactly. So he worked on some of the outreach Microsoft did to various political campaigns last year.
Yes, sir.
So
I remember his talk was called how data determined the election. And I asked him, so was data right? Apparently data was wrong. It was like way wrong. Right. But there were really good reasons for why it was wrong. Right. That was a fascinating talk. I don't think he'll do that talk because that was a Microsoft talk, and he's no longer with Microsoft. But
well, he'll be a little bit more honest this time, maybe. Who knows?
Maybe he can. Yeah, whole different talk. So likewise, if you're interested in doing a webinar, I would love to hear from you, because I love talking to people out in the community. Just send us an email at info@swiftkick.in. Also, if you don't speak, but you kind of have things you want to learn about, also send us an email and ask us about different topics that you're interested in. We're starting to book out a couple months worth of webinars, and it just would be nice from my standpoint to try to get a particular person if you're interested in a person or a topic. But I'm done talking. I've been talking way too much. You really want to hear from Frank. So I'm just going to turn it over to Mr. Frank Vigne. You should go to his blog at franksworld.com. And also follow him on Twitter at Tableteer. So Tableteer, you have to give the backstory of how I knew you when you were actually doing tablet work.
Right. So once upon a time, before the iPad came out, Microsoft had something called the Tablet PC edition for Windows XP. And I was fortunate enough to be in the right place at the right time to work on a project, basically an EMR, electronic medical records project, that was using the tablet PC so doctors could write out notes and whatnot. And when I explored the SDK, I was like, everybody should know about this because it was pretty awesome. And so that's how I started my career in the community, basically preaching about that. And I was inspired myself by people when I lived in New Jersey, people like Don Demsack, or Don XML as he was known, Miguel Castro, who's still pretty famous, talking about kind of .NET in the community. And that's how I started. I started my career more in the Java space than in kind of the Microsoft space. So
really, I didn't know that part.
Oh yeah. I used to be a Java developer, and before that a Perl developer. So it was an interesting ride. I actually was at BarnesandNoble.com before it spun off into its own company. So I was there at the beginning of Silicon Alley.
Wow.
So very, very interesting story. So it's kind of funny seeing kind of where Amazon is today versus where Barnes and Noble is today. He clearly had a bigger vision than just fighting about books. But with that, let me start my presentation.
Yes, sir. Go ahead. And if you have questions, there's a special Q&A section of the chat. And when we get to the end of the presentation, Frank will answer all your questions.
Right. Maybe not like the meaning of life type questions, but I will answer many questions. All right. Is that
all right? You're on, Frank.
Is that flashing, or is it just looking normal?
It is flashing.
That is weird. It worked fine in the tests.
Yeah.
It worked on my machine.
It's all right.
There we go.
You're good. All right.
Awesome. All right. So my name is Frank Vigne. This talk, I wanted to call this Fear and Loathing in Data Science because it really focused on kind of the last 12 months for me had been very interesting. And in a way, it was kind of like a country music song. I mean, you know, my mom got sick. I was told that my job was moving to Redmond, and even the cat died. So, but in all of it, I discovered a new passion and love that was data science. And as we deal with kind of being a developer, there's going to be career changes, you know, in our future. That's just the nature of the beast. My pre-talk just now was kind of a good segue from that. You know, I was a Perl developer, then Java developer, then .NET developer, then a tablet PC MVP, and then I even did a lot of Silverlight, if you even know what that is. But so this is kind of the journey that I went on from becoming a developer or software engineer into a data scientist, and how that is a transition. I think at some point we'll all be doing some measure of data science in the not too distant future. Once again, you can reach me at Tableteer, which I've never changed that Twitter handle, though I wonder if I should. Because some people pronounce it table tier, which is kind of annoying. And you can reach me at franksworld.com or my podcast about data science called Data Driven, and that's at datadriven.tv or wherever podcasts are downloaded. Did you say something, Kevin? I couldn't hear you.
Oh, I'm silent.
Oh, okay. Sorry about that. All right. And now I am very proud to be the data analytics practice lead at Wintellect. All right. So we will start off the story here. If you're familiar with the movie by the novel and movie by Hunter Thompson and Terry Gilliam, then you'll get a lot of some of these jokes and the gifs. But if you're not, then if you're inspired to see the movie, I would caution you to think twice about that, because it's kind of a strange movie, and I don't want you to say, "Hey, this Frank guy said to do it." All right. So who is Wintellect? Wintellect. I love Wintellect. I'm super excited, as we say at Microsoft, to be on their team. They are kind of a big deal. We have some good old fashioned legends, and every time I'm on a phone call or a Slack channel conversation with any one of these guys, I feel special, and it's a true privilege to work there. And I am really excited to be there and build out a awesome practice there. But let's go back and start where this journey began. So I was somewhere, I live in the Washington, D.C. area, so I was somewhere along the Maryland, D.C. border when the realization took hold. My job was moving to Seattle, and when they ask you to move to Seattle, you have an option of moving or else. And I decided to take the or else option because I have family commitments here on the East Coast that really make it impractical for me to move. So I took the or else option, and I basically got a package and was laid off. And I basically spent the last few years focusing on kind of that path from going from Silverlight to WPF to Windows 8 apps to Windows Phone apps, and ultimately into what's known as Universal Windows Platform apps. While I love Windows Universal Platform, it's a great platform. It's very flexible. You could do a lot of fun things with it. It really ended up kind of being the new Silverlight, if you will, in the terms of whenever I spoke to recruiters, this was kind of the reaction I got that I was an ASU WP developer. So that was not exactly what I was expecting or what I had experienced before. So what was I doing at Microsoft? Well, I had a very unique job. I started Microsoft as an evangelist, which is one of the coolest jobs I think I've ever had. And I was focusing primarily on developer evangelism. And then about 2-3 years ago, I had an opportunity to join a team focusing on civic tech. And you're probably wondering what civic tech is. Civic tech is the idea that technologists can help inform elected officials on technology issues, but also basically be citizen developers or citizens that can kind of volunteer their time and effort and leverage government data and build out new services for people. So whether that's, I'll build an app, make it free, and then if you take a picture of this pothole, and then that'll send an email automatically to City Hall, and then hopefully they'll fix that sooner. But one of the more interesting aspects of my job is I actually worked on K Street. Basically, I would present to policymakers, visiting dignitaries, elected officials, even a vice president. And so I like to compare my job as kind of a cross between the IT crowd and House of Cards, which was pretty, it sounds as weird and unique as it does, because it was very unusual. But one of the things I noticed is when I spoke to a senator or a foreign trade minister, they weren't really interested, obviously, in the things that developers were interested in. So one of the things that I kind of added to my demo bag of tricks was creating data visualizations and basically pulling all this data from freely available government data sets, whether that's from the Department of Energy or from local sources like the city of Chicago, or from the National Weather Service or NOAA. So that really got me exploring kind of data and getting my hands dirty with data. So then I had the opportunity to attend. Microsoft has a lot of internal training events, which is one of the great things about the company. And one of the training events was the Machine Learning and Data Science Summit. And I kind of went in as kind of I know Excel, I played around with Power BI. I've heard of the AI and all this stuff, but what does that really mean? But I really had my moment of seeing the light of what I wanted to do next. I really like UI. I really like building out good UX. I really like building apps and solutions. But one of the things this really touched on me is a new passion, a new fire for building out data science solutions, or not so much data science solutions, but being able to take raw data, which in its raw form is somewhat useless, and turn it into something useful. And that's when I discovered the joy of data science. And really, that always, when I talk about that, people always ask me, well, what is that? What is data science exactly? Obviously, it's the hot thing. That's all people could talk about. Machine learning this, AI that. There's AI now in PowerPoint 365. What does this mean exactly? Even Harvard Business Review, an organization not known for their sensationalism, calls data scientists the sexiest job of the 21st century. But data science isn't really that new. Things like neural networks have been around since the 70s. Initial thoughts in artificial intelligence go back to Alan Turing, which was shortly after the World War II ended. And a lot of what you see, what we call data science or machine learning today, looks an awful lot like predictive statistics. But there's other terms that get bandied around. I already mentioned AI, right? ML. What's RL, right? Does that mean real life? But what that actually is that's reinforcement learning. And I'll kind of cover what that is. But math. There is an awful lot of math involved in data science. And most people, when you tell them about math, this is their reaction that you get from them. And but one of the things that I learned through the process of getting certified or going through the courses and training, that a lot of this is available online for free or very cheap, is that, to paraphrase the opening line from the book and the movie, he who makes a statistician of himself gets rid of the pain of being a data scientist. And I took a lot of math in school. I was never a big fan of math. But one of the things I've learned as I've matured and gotten older is that math is much better when you understand the purpose. You're not just dividing X into Y just for giggles. You're doing it for a purpose, and that's why. So I basically took the package that I had and set aside some time to focus 100% on learning data science and really getting like deep into it. And I'm very glad I did that. It's very refreshing to be excited about a technology stack again. And I'll talk about the edX class later, and I'll be happy to field questions about that. But you're probably wondering, who is a data scientist, right? Well, there's an old joke, and it's basically a statistician who can sling code, or a coder who can understand statistics. And that's not entirely false either. Even though it's a joke, there's a very large grain of truth in that. But the serious answer is that, well, there's really no clear definition of who a data scientist is and who a data scientist isn't. Excuse me. They typically, if you see the ones on YouTube, when you search the term data scientist, they typically have PhDs or other advanced degrees in math and statistics. They can also be data architects and software engineers, or just subject matter experts. So what data science really is a convergence of disciplines. It's a mashup, if you will, of math and stats, software engineering, and data communication, or the ability to tell a story from data, aka data visualization. And that is really what it is. So if you're already a software engineer, the good news is you already have the software and the hardware to be able to do this type of work, because it's not that much of a jump. It's a little bit different of a world. Or put another way, basically you have people who are experts in computer science. That's, if you're watching this, that's probably you. And you may even have subject matter expertise. So if you work in healthcare as a software engineer, you have two of those three things on that Venn diagram. So the best thing for you to do is to kind of bone up on your math and statistics information. And then, as you see, kind of basically the idea is that, they're called unicorns, because the people who excel at all three of those fields, and I mean world-class at three of those fields, is a very rare animal. And that's really kind of the people want. There's a myth in data science today, and it's starting to break down because the market can't support it. More and more companies need their data analyzed. There's a finite number of people who are expert level in three fields like this. And basically, there's a notion, I think Microsoft coined a phrase for their consulting service called the data science team method, where basically what you're really going to find is it's more efficient and effective, cost effective, to hire three people instead of looking for that one unicorn that knows it all. And nothing against unicorns, but unicorns are rare and expensive. So your next question is probably why do you call it science? Why is it called data science? Well, a big part of that is because a lot of this involves the scientific method. So if you're not familiar with the scientific method, the idea is that you make an observation. I sell more hot chocolate on cold days. Or I sell more cold lemonade on hot days. Did I mix that up? But you get the point. So basically, you observe, and you come up with a theory. Well, I think that if it's really cold out, I'm going to sell more hot cocoa. Or if I place my stand at a place where more people are going to gather, I'm going to make more sales. Is that true? I don't know. But that's the theory that you propose. So then you come up with a prediction. I'm going to open up a hot cocoa stand, and I'm going to put it in the middle of Antarctica, right? Because certainly it's very cold, but I'm not going to get a lot of foot traffic. Versus I'm going to go to a ski slope, and maybe at the bottom of the ski slope, I'm going to sell hot cocoa. And who's going to get more? Basically, I come up with an idea of what I'm going to predict, and then I experiment. I set up my stand, or I take data from somebody else who's going to take up a stand. And then I see how that plays out. And that's basically what it is. I come up with an idea where I think there might be a correlation between X and Y, number of polar bears per square mile versus how many, hot cocos I sell, and that sort of thing. And I find if there's a correlation. So that's basically it in a nutshell. And then if I'm wrong, I go back and I adjust my my theory, and then I go and run the test again and again and again. The idea is that I create a model for how to sell more hot cocoa, right? Maybe ice rinks are a better place than ski slopes. Maybe waiting outside a movie theater or something like that. I mean, you just tweak the parameters of the experiment till you have your answer. So one of the other things that's very intimidating for people getting into data scientists is all the buzzwords that exist in this field. And when you do a quick search on YouTube, you'll get very academic kind of proposals, and they'll start spouting off terms that, quite frankly, sound like Charlie Brown's parents. They'll say, hey, well, first we're going to take the data, and then we'll run it through a algorithm, which will then, so it's important to understand kind of the overall picture and structure of what this field is about. So here's kind of a map. I'm not 100% convinced that this map is perfect, but it's a good starting point to you figure out how these things correlate to one another, right? So first, on the right, you have artificial intelligence or data science. That's kind of the overall catch-all term for this. And then you have the idea of machine learning. And inside machine learning, there's predictive analytics and deep learning. Natural language processing is basically the idea that you can take human written language, whether it's said or written, and then you can extract information from it. You can cluster the data. Are we talking about sports? So if I say the word boxer, right, how can I infer from context? Am I talking about the type of dog, or am I talking about the sport? You can also do translation from language to language, right, because context is obviously important in that space. You can also do something that's very popular. I know it was done extensively in the political space, was sentiment extraction in terms of, people are tweeting about person X. Is it mostly positive, mostly negative, or is it about their stance on a particular issue? Obviously, text-to-speech is another type of thing. If you have an Alexa or Google Home in your house, then you know how useful and how powerful that can be. There's also computer vision, image recognition, as well as kind of understanding what you're seeing. You're going to see that, I think, pop up more and more in terms of, we have millions of cameras. What is actually the camera seeing? And you can do that. Self-driving cars are going to play a big part in that because they'll be able to interpret in real time what the car is seeing. So here's the key difference. This is the thing that trips up most software engineers. We're used to writing algorithms, right? That's what we do. That's our bread and butter. And the difference here is instead of writing an algorithm to solve a problem, we assemble algorithms. The algorithms that we use already know how to figure stuff out on their own, right? So you don't write a program to solve a problem per se. The algorithms that you use have already been figured out by extremely smart people who have dedicated their life to math, and the algorithms solve things for themselves. Now, where humans are needed, at least for the time being, is the ability to pick out which algorithms are needed to solve the overall problem or to figure out the problems for themselves. I know that's kind of tricky, but bear with me. So basically, that's the essence of machine learning, that a machine is not so much programmed to solve a problem. The machine is programmed to solve problems on its own. So we're not going to write an algorithm to say, if temperature is below this, then do that. If temperature is above this, you're basically going to feed two algorithms. Here's the data that I have on sales. Here's the data of where I was when I made those sales. And the computer itself will work out the patterns. That's machine learning. It's basically the software is doing things that it was not directly programmed to. It figured it out for itself. And there's really three types of machine learning to consider. There's supervised learning, unsupervised learning, and reinforcement learning. So you're probably thinking, well, what does that exactly mean? All right. So for example, given a picture set of cats and dogs, supervised learning is when you label the data. So you tell the computer, here's a picture of a cat, there's a picture of a dog, and you feed it basically one by one. Say, here's what a cat looks like. Here's what a dog looks like. Here's what a cat looks like. Here's what a dog looks like. So the ground truth is always no. Unsupervised learning is you just hand it a bunch of pictures. You don't tell it which one's a cat, which one's a dog. The computer will then work out through clustering means where it'll cluster the pictures of cats in kind of one category with those attributes, and it cluster the pictures of dogs in another. It doesn't necessarily know which is a cat and which is a dog. It just puts it into different categories, two different clusters, if you will. Now, reinforcement learning is an interesting, relatively new innovation. So reinforcement learning is you basically reward the computer for the right answers, and you punish the computer for the wrong answers. Now that sounds, how do you punish a computer? How do you reward a computer? Do you give it a cookie? Do you take away its internet privileges? I don't know, but bear with me. So the idea is mimics the most like the way we as humans learn. So if you were a kid and you think back to you saw a dog and you pointed to it, or you just saw it, you saw an animal, and then an adult next to you said, "That's a dog." That was a doggy say. Doggy says, "Woof woof." And then you next day you saw a cat, and then you would immediately, maybe you assumed, "Hey, that's another dog." And the person like, no, that's a cat. And then as you saw animals in the park or in different environments, and you would say, "Oh, there's a dog." If you were right, you got, "Yes, that's right, that's a dog." If you saw and you got it wrong, your person would say, no, that's this type of thing. So that's kind of reinforcement learning. Now let's talk about cake. So the important thing here is to talk about data. So in unsupervised learning, you need a lot of samples. You need to throw a lot of data. So a lot of pictures of cats, a lot of pictures of dogs, for the computer to kind of work out where those clusters would be, where those clumps of these are pictures of cats, these pictures of dogs would be. So you need a lot of samples. You need a lot of data. With supervised learning, the icing on the cake, if you will, you need less samples because the computer can kind of say, "Oh, well, I know what this is supposed to be. Let me see if I can figure out what it's supposed to be." Now, what's really interesting is reinforcement learning is really the cherry on top here because it would require the least amount of samples. In fact, there's some research going into what's called one-shot learning, which means the idea that you can only expose the computer to, say, observing something once, and it will actually learn what to do. And we as human beings, we are awesome at this. I mean, if you right now stop what you're doing and I say, "Do exactly what I do," whoops, except for knocking the microphone out, right? You put your hands up, put your hand down, right? You can mimic that with astonishing accuracy. And that's basically the notion of what this reinforcement learning is. So let's talk about kind of the importance of decision boundaries. Now, the best thing to do right now is to test a neural network live here on this webinar. And you're probably thinking, how are we going to do that? What's the technology we're going to do that for? Here's the thing. We're going to test your neural network, the one that has been, you have been training since the day you were born, even though you didn't realize you were training it. And we're going to run a test here. And we're going to say, I'm going to show you pictures of cats and pictures of dogs. And you have to tell me which one it is. But remember this here. Remember this graphic here where we're talking about decision boundaries, because it's going to matter in a little bit. It'll make a lot more sense. All right. So if you're ready, I'll start the test. The first question is this a cat or is this a dog? So congratulations. If you said this was a dog, you are correct. All right. Are you ready? Is this a cat or a dog? Congratulations if you said this was a cat. Now, so far you're 2 for 2, but don't get too smug. Ready? Here's the next image. Is that a cat or is that a dog? Now, as you study, as you kind of look at the picture, notice what you're doing. Be aware of what your own neural network is doing. You are actually studying the features of that thing to figure out, well, is that a cat or is that a dog? What are you doing? You're probably waffling between the two. You're probably thinking, no, it's a cat. No, it's a dog. And there's probably a number of things you're running through in your head, right? The nose. Well, I can't tell if that's a dog nose or a cat nose. Certainly the hair obscures a lot of the features. The eyes kind of look like cat eyes, not so much dog eyes because you have that curve. Other things that you would notice, the pointy ears, that sort of thing, how big it is. There's no clue here in terms of is this an 80, 90-pound Weimaraner or a little Chihuahua type-ish dog or Yorkie, or is this just a cat? So a number of things are going on inside your brain right now that are kind of confusing it. And a lot of that is because this image, this sample is really on that decision boundary. So in other words, let me use the really cool laser pointer here. You are that sample there. So if I showed you a picture, the first picture was definitely a dog, right? There was no question about it. It was very clearly a dog. Second picture was very clearly a cat. So it was definitely on that side of the boundary. But what we saw in that last animal was something that was very hard to kind of differentiate. And part of that is that the fact that it had elements of both in it. And I know from where I got that image is that it's actually an image of a cat. And, before I knew that, I waffled back and forth on that too. But the idea here is that the sample data you feed it, you have to be very careful how you train the neural network. So a lot of that is going to depend on the sample data that you put in. So if you put in a non-diverse or just bad sample data in, you're going to get bad decisions or the bad decision boundaries out. Garbage in, garbage out. This is not a new concept for us. Now, also, distance from the decision boundary matters. So this is probably best illustrated. So I live in Maryland. Maryland, basically, I live in a suburb of Washington, D.C. So a lot of questions I get is, well, where is the boundary between who considers what is considered in Maryland a DC suburb versus a Baltimore suburb? And while that is somewhat subjective, I will say that a good example of how you determine that line is if you go to the local big box store, Target or Walmart, and what are they selling on the shelves? Are they selling Redskins gear or are they selling Ravens gear? That does seem to be maybe I've always been a data geek, but when I first moved to Maryland, I kind of made that observation, and the general unofficial consensus is basically Maryland State Route 32. If you're north of State Route 32, you are very clearly in Baltimore territory. If you're south of State Route 32, you are very clearly in DC territory. And most of the stores kind of bear that out. Am I saying that there's no Redskins fan north of Route 32? No. Just saying the chances are it's going to be more likely to be one or the other, whether you're north or south of that line. So in this case, that's the decision boundary. Is it perfect? No, it doesn't have to be. It's kind of the idea that, clearly if I'm way further north than that state line, there's a chance that I'm going to be more a Ravens fan, way more of a chance. But as you get close to that line, it's probably kind of fuzzy. And that's basically it. This animal here is fuzzy in more ways than one. All right. So now here's another thing that's pretty interesting. So we as human beings, we're used to dealing in 3 dimensions. And it's hard to explain what that exactly means. So here's a good example. In plot A, if the data points in there are only aware of 2 dimensions, the shortest distance between those 2 lines is what? You basically go along that spiral. Now, if it were aware of 3 dimensions, the shortest distance between those 2 points are basically a point right through 3D space. So one of the things you could do with data that you can't do in real space, at least physicists haven't figured that out yet, is the ability to warp space inside a mathematical model. It's best explained if I do this. Right, so here's an example how could I draw a straight line that basically neatly slices through, separating the yellow circles from the red circles? And the answer is you can't. There's really no way to do that. But what if I added an extra dimension, an extra dimension to this? So I would start out with not being able to do it to suddenly the difference becomes quite clear. And the idea here is that by adding more data or more dimensionality, you actually can compare things in much greater way. And this is probably what you're thinking right now. Whoa, yeah, this is really cool. And there's no real hard limit in terms of how many dimensions you can add to your data. So I did a data science project once. It had 400-ish dimensions. This is where computers excel. Beyond a certain amount, we can kind of imagine, clearly we could do 3 dimensions with some creative visualizations. Think the famous one from history, plotting the French army's losses after invading Russia. They were able to graph 5 or 6 dimensions on one 2-dimensional chart with really cool tools and stuff and shapes and colors. We can get up to probably about 7 or 8 dimensions we can very easily differentiate from. Computers do not have that limitation. So I was able to do a dimensional analysis from that. Now, obviously, sometimes having too many dimensions is just too much. That's something you're going to have to get a feel for over time. Now, you've seen me talk about kind of the concepts of data science, and hopefully, hopefully you're still awake, and 2, you're really curious about this. So you're probably, if you want to know how to do this, how do I become a data scientist? Well, it's easy and it's hard. And it can be expensive or not very expensive, or not expensive at all. The worst advice I ever got from a data scientist at Microsoft was he told me just go back to school and get a PhD in it. Now, I don't think he realized how arrogant that sounded because everyone he knew had a PhD. It was just, it was kind of like, oh, I go to 7-Eleven and pick one up on my way home. But the best advice I ever got was this right here. Just do it. The best way to learn is just by doing. Think about how you became good at software and coding, right? How you became good at software engineering. You just learned it by doing. And that's the best way to do it. And with the tools and software that are available out there, this is not a hard putt. I personally chose to do the edX route because edX, it's about 10 or 11 courses and they're about $100 each. Contrast that with a big Ivy League engineering school. It was about $40,000. So you can spend anywhere from $1,000 to $40,000. Or everywhere in the middle is an option. There's also, if you don't want to get the paper certificate, every class on edX is free. So if you don't want to have the certificate to prove that you went through it, not a problem. You could do it for free. There's also datacamp.com. There's also a number of courses I'm developing for Wintellect, and colleagues of mine are developing for Wintellect to solve just this very problem. So here are some interesting people to follow on Twitter who are really big names in this space. I humbly submit my name last to that list. There's also a number of YouTube channels that are available. Suraj Raval, right after this, stop what you're doing, watch some of his videos, look at his name. He is awesome. He has got some of the funniest videos and best video production that you can imagine. Check his stuff out. It's pretty awesome. He has a whole series called The Math of Intelligence, where he goes through basically reverse engineering how these things kind of come up based on real world problems. And he is awesome. PyData runs a series of conferences around the world. They put a lot of their sessions up online. Most of those at first are going to sound just like Charlie Brown's parents did. But keep at it. You'll learn it. I really like Zettabytes. That's a pretty interesting interview style format. Becoming a Data Scientist is also an awesome podcast / YouTube channel. There's also Frank's World TV. And there's also a podcast I have that is focused on basically our target market, are people that we want to address. Our avatar, as they call it in podcasting marketing circles, is people who are data professionals or software engineers who want to learn data science. And we've launched this podcast. We have 22,000 plus downloads since we launched the Memorial Day. It's basically myself, the software engineer, and Andy Leonard, who's more of the DBA kind of professional data guy. And we get people on the show that are pretty interesting folks. And not to brag or nothing, but a lot of the folks in the keynotes from Ignite the other week were actually already guests on our show. So we were like, yes. If you want to be a guest, just hit me up. So I recommend you subscribe to the podcast, rate and review it. Check it out. We have a lot of fun with it. There's also a secret project Andy and I are also working on. If you like to write about data or about anything like this, just shoot me an email with that subject. Things will become clearer in the near future. But like all good projects, it is currently behind schedule. So, but it is still pushing forward with it. So with that, I want to say thank you for being an awesome audience. For that, I will just put up on the screen here. Let's see. Here's some cool stuff. So right now, the class is free on Wintellect now, which is basically data science for devs. And as you see behind me, I have a green screen. I really got into video production. I have one of these. I had a lot of fun with making it. We've also have Audible as a sponsor of our podcast. So you can actually go to thedatadrivenbook.com, get one free audiobook on us. The podcast is datadriven.tv, and Wintellect pays my bills. So I will give them one more shout out to talk about our data analytics practice. That's it for me, Kevin.
Awesome. Well, thanks so much, Frank. We really appreciate you having, and that was really, really insightful. So folks out there, if you have any questions, Frank is here to answer them. And anyone watching the recording of this, you can also type in questions, and those get sent to me, and I can pass those on to Frank to answer through another means. Frank, you just got a question in the chat from Martin. Can you give us some real-world examples? For example, what are you working on?
So what I'm working on right now, I have a number of hands-on labs that I'm working to build out for a large software company. Can't say who they are, but you can probably figure it out. I'm also working on a Power BI dashboard to demonstrate for a potential customer how to take data from numerous IoT devices and aggregate that in through Power BI and see it on a map in real time. So you'll be able to tell, the plan is you'll be able to tell in real time diagnostic information from devices, theoretically from around the world, but we only have it in two test cities. That brings up another point too. IoT and data science, well, not directly aligned. They kind of feed into the same things. IoT devices are ultimately going to generate a lot of data. That data then can be mined and monetized based on patterns that you see. So one of the projects I did while I was at Microsoft was and I talked about this at Revolution Conf, was what we called Frosty the Snowbot, which basically was think of the guts of an electronic scale, but it was web connected. So the idea would be that you could, the city of Boston, who it was built for, before they can decide a public building can be open, and if it snows over a certain amount, they have to determine whether or not the roof can withhold the pressure that's being put on it. Now, on a normal winter, they have a team of like 5-6 guys. They drive around, they weigh the snow. Under a normal winter, that's not a big deal. If they have a really crazy winter like they did 2-3 years ago, that's a problem because they have tons of structures to do. So the idea for this would be you would actually know what the load on the roof was in real time. So you didn't really have to send anyone out. You could just sit from a dashboard, kind of click around and say, this building has so much load on it. It's 80% of capacity, and our safety threshold is 75% capacity, right? So then we can say, no, that building can't open today. Or do we prioritize something that is at 99% capacity, evacuate it right away, or do we send a team out to like kind of start shoveling off the roof right away? That was kind of the purpose of it. But like all government projects, it's been delayed, and the fact that they've had a couple of mild winters has really lowered this on the priority list. I see another question.
We do from Seth. He's getting he's as a junior software engineer. He's finishing his MS in software engineering. He wants to know, what's the best time to start learning data science?
The best time is always now, which is easy for me to say. If you're finishing your MS, just work on that first. Also, start thinking about kind of big data problems, or just start doing thought experiments about, learning Hadoop and things like that. I think learning Hadoop and Google, the history of that, and how Google had a problem of collecting all this data and collating all this data, and MapReduce and the invention of that is pretty amazing stuff. And I'm sure that'll definitely, because that's a software engineering problem. Because at some point, this stuff that we're collecting, ceases to become an academic problem, and then becomes a engineering problem. So here's one example. I heard a story that from, actually, it was one of our podcast guests who basically had shared that she was hired as a consultant to a major company, and she was told to gather the resumes of 50 top data scientists, and they all had to have PhDs. So story goes that as he interviewed them, they had no idea what ETL was, which is basically a common term in data engineering, where extract, transform, and load. They had no idea. Now, they knew everything about the science of data, but they didn't know anything about the engineering of data. And I think that what's interesting about this field right now is that the academic side of things is starting to collide very hard with the practical engineering constraints that we have in the real world. I don't know. Hopefully that answers your question. But I would say start taking a look at this. If you're currently in school, you're probably learning Java. That's good. You're probably learning Python. That's good. But I would say there's plenty of free resources to learn this just on YouTube.
All right. And there's also an excellent course on Wintellect now.
Yes. It's basically this course that, it was basically, it's a different version of this talk that I gave, but with much more special effects that'll do that. We have a new question. How long did it take me to learn data science or complete edX? The Udacity course on ML takes about 5 months. Coursera has some even longer programs. And of course, there are 2 years master's programs out there charging $60K a year. Yeah.
Frank, so I do it for $30K a year. Just pay me directly.
Yeah, right. I'll undercut you. 25. No. Yeah. This really depends. I mean, what you're really paying for in that $60K program is whoever you're paying for that sheepskin, and you're also paying for the name that's on the top of that sheepskin. So I think MIT is on. I think MIT, when I first looked, for just a certificate was $45,000. Now that's, I looked at that. I looked at that seriously. But I was laid off, and I had gotten a nice package from Microsoft, but I wasn't sure how long it would take for me to do that. So I opted for the edX thing because that was a Microsoft certified thing. I was kind of a fiend. I had no day job, so I was able to just focus entirely on that. I did it in about 6.5 months to go through the edX thing. To retool and kind of stop what you're doing is about a 6-month minimum commitment. I still take classes. I'm in the middle of the Cosmos DB edX class right now. I have a subscription to DataCamp, datacamp.com, where they basically walk you through how to do stuff in Python and R. Although I'm focusing primarily on Python for a number of reasons that are kind of random. So I would say, and even before I had left Microsoft, I was doing kind of tangential data science. I thought it was data science because it was like, oh, cool, I'm learning Power BI. Or I'm learning how to do stuff 3D mapping in Excel. But there's more to it than that. And I would say realistically, minimum is going to be about 6 months. Maximum could be 2-3 years. I think somewhere in the middle there. I mean, it really depends on what your goal is. If your goal is to become a data scientist, There's a really cool YouTube video out there where this also inspired me. She basically, it's called like How to Become a Data Scientist in 6 months. And it's basically just kind of do what I did, which is just focus on this. Every spare moment, is learning this. Yeah. There's also a number of free, and as the market for this is more in demand, there's a lot more services that are available now than they were, say, maybe like a year ago. Hopefully that answers your question. Yeah, but the $60K a year thing, that's mostly for people whose companies pay the tuition. It's not for average Joes or Janes on the street.
Well, awesome. Well, we'll go ahead and, all right, Seth has one more question. This will be our last question for today. Frank, you live in the DC area. What do you think of the boot camps in the area, like General Assembly or George Washington for data science or machine learning?
So I have great respect for General Assembly, but I know they cost quite a bit of money. If I heard the number, I don't know if this is true. I have no data to verify this, but I heard something to the tune of $10,000 plus for the boot camp for data science. Wow. I'm sure it's an awesome program, but if you live in the DC area, actually it doesn't even matter because they do it online. Hopkins, you get a certificate from Hopkins for $15,000. So I love General Assembly. Hopkins is also a big name too. So, I mean, do your research. I mean, that's the best thing to do. Collect more data, if you will, and see what works for you. But I think there's also a practical limitation of how long do those boot camps go? Are they like 5 days or 5 weeks? There's only so much your brain can absorb and process at once. It's going to take you 6 months range. It's going to take you months to learn a skill like this. It's not going to be something you can kind of do in those 3 months. It's going to take you months to really master this, but I would say do some investigation on terms of, what they offer. What do you walk out with? Do you walk out with a guarantee of a job? I don't know. I mean, maybe I'm slow. Maybe I'm dense and slow, and it took me 6 months when it could be done in 3 months. I don't know.
You didn't want it hard enough, Frank.
I swear I did it. I did every time I passed the class or certificate program, I printed it out, hung it on my wall, and I think my record is 5 certs in a month. That was a crazy month.
Mm-hmm. Well, all right. Well, we'll go ahead and cut it off there. If you have any questions at all, reach out to Frank on Twitter, or if you're watching the replay, of course, type it in the box and I'll get an email. With that, Frank, thank you so much for joining us today. I think the folks who were with us got a lot out of it, and of course, this replay will be available for forever. Nothing dies on the internet, so this is stone history now. Those of you, you'll also get an email from me sometime next week about our new upcoming webinars, and I hope you can join us for those as well. But thank you again, Frank, and thank you to our great gracious audience.
Thanks for having me.